Hello everyone, my name is VINAY SAI RAMARAO PERALA. This is my final project on tower building design by Skyfi Labs. In this project, I'm going to design 23-story tower building using ETAP software. This is the data provided by Skyfi Labs for this project. So there are 4 different sets of stories and having different live loads and having same dead loads of 2 kN per meter square. Coming to beams and columns, they have mentioned 3 different dimensions for columns and beams, and we need to use auto select. So in this project we're going to use M40 concrete, HYSD 500 and mild 250 rebar. Coming to slab should be of 150 mm thick and should be of M40 grade concrete. Here we are using auto draw cladding, and they have mentioned auto cladding load of 0.2 kN per meter. Coming to wind load, we need to consider parameter as in Bangalore. Open ETAP software and click on new model and use built-in settings with display units as metric SI and design codes as Indian standards. Check the Indian design codes for concrete and steel. Click on OK. And now grid dimensions. The number of grid lines in X and Y direction is same, that is 4, that is mentioned in data. And the spacing of grids in X and Y direction is same, and they have mentioned 6 meters as the spacing of grids. So change the value to 6 meters. And coming to story dimensions, the number of stories in this building is 23. So typical story height and bottom story height is same, that is 3 meters. And click on custom story data, edit story data. So by default, story 23 is the master story, but in the data they have mentioned 4 different sets of stories. Uh, those are story 1 to 8, story 9 to 14, story 15 to 19, and story 20 to 23. So we need to change the master stories for respective set of stories. So for story set, story 1 to story 8, the story 8 is a master story. So we need to change story 8 to the master story. And story 7, 6, 5, 4, 3, 2, 1 are similar to story 8. So we need to change to story 8. So now moving to another set, 9 to 14. Story 14 is the master story. Story 13, 12, 11, 10 are similar to story 14. Now we are moving to story 15 to 19, and 19 is the master story. And by default story 23 is the master story, so there is no need to change the master story. So and 22, 21, 20 are by default similar to story 23. So click on now OK. And in the structural objects we select grid only and click on OK. So there are 2 tabs, plane view tab and 3D view tab. So we need to define the under define we need to define the material properties and section properties. First we will define the material properties. So we need to define M40, HPS 500 and my 250 rebars. Click on add new properties and select material type concrete, region India and grade M40. And these are the material property of M40 grade according to IS 456 2000. So there is no need to change the property data. So click on OK. Click on add new material. Click on material type, rebar, standard Indian and HPSD 500. Click on OK. Click on OK. Add new material, rebar, grade mild 250 grade. Click on OK. Click on OK. So now we have added M40 HPSD 500 mild 250. Now we need to define the section properties, that is frame sections and slab sections. In frame sections, we define the columns and beams, and in slab section, we define the slabs. Under frame sections, we will define the columns first. A new property. Column is of concrete and rectangular shape. So add concrete and give the dimensions and property. Give the property name as column 500 by 500. And material type HPST material M40, and give the depth of the column is 500 by 500. And under reinforcement modifier show rebar, the longitudinal design type is column and longitudinal bar is HPST 500 and confinement bars is mile 250. According to IS 456-2000, the clear cover to confinement bars is 40 mm. So there is no need to change the clear cover. So click on OK and click on OK. So we are adding another property of column. Give the property name as column 550 by 550, material of M40, depth 550, width 550, and under reinforcement modifier show bar, design type column and longitudinal bars as HYH 500, confinement bars as mile 250. So click on OK, click on OK, and now add new property and concrete rectangular and column of 600 by 600, and material type M40, depth is 600 mm and width is 600 mm, reinforcement modifier show rebar, and design type column and longitudinal bars as HPST 500, confinement bars as mile 250. So click on OK, click on OK. So we need to define another property, that is column auto select. So for that, add new property, and then under special there is auto select option. So we are given the property name as column auto select and design type as concrete. So now we need to add these three column properties to the auto select list. So select these three column properties and add to the auto select list, and column auto select is defined. And now we need to add another property. Now we need to add beam properties. So click on concrete rectangular. So it's beam 500 by 300, and the material type is M40, and depth of the beam is 500 and width is 300. Under modifier show rebar, design type should be beam and longitudinal bars should be HY 500 and confinement bars mile 250. According to IS 456-2000, the cover to the top bars and bottom bars is equal to 25 mm, and changing that to 25 mm. And click on OK. Okay. So again another property, concrete rectangular. Now we have given property name 550 by 350 and material type M40. Depth of the beam is 550 and width of the beam is 250. Modifier show rebar, and design type should be beam and longitudinal bar is 500 HPST, confinement mile 250, and cover is 25 in both top bar and bottom bar. Okay. Okay. Adding another property, concrete rectangular, beam 600 by 400, material type is M40, and depth of the beam is 600 mm and width is 400 mm, and click modify show rainbow. Under design type, select beam and longitudinal bars as HPST 500, confinement bars as mile 250, and cover to the top bars and bottom bar is 25, and click on OK. Click on OK. Now we need to add beam auto select properties. So click on add new property, and under special select auto select list, and then give the property name as beam auto select, and design type as concrete. Now select these three beam properties and add them into auto select list. So now beam auto select properties defined. So click on OK. So now we have different frame sections, that is beams and columns. Now we need to define the slab sections. So under define section properties, slab sections, a new property, and property name is slab 150, and material type is M40, and slab should be of thickness 150 mm. So click on OK. So click on OK. So far now we have defined the material properties and section properties. So now we need to draw the columns and beams and slabs for each set of stories. So now moving to story 1, select similar story. So we will draw the columns, beams, and slabs for story 1, which are similar to the other stories. Okay. So we are drawing for set 1 to set story. Sorry, we are drawing columns and beams and slabs for story 1 to 8. So click on Fig, draw columns, and property select column auto select, and select the joints carefully. And after that, we need to draw the beams. So for that, quick draw beam option is there, and click on it. And property select beam auto select, and draw the beams carefully. And now to draw slabs, select quick draw floor wall, and change the property to slab 150, and draw the beams slabs. Sorry. So far now we have drawn the columns, beams, and slabs for story 1 to 8. Now moving to story 10. So we will draw columns, beams, and slabs which are similar to story 10, that is set 9 to 14. So click quick draw columns, and column auto select, and select the joints carefully. So joints are selected. Now we need to draw beams. So for the quick draw, beams should be selected, and draw the beams carefully. Now we will draw the slabs. So select quick draw floor wall plan, and draw the slabs. So we have drawn column, beams, and slabs for story 9 to 14. Now moving to story 16. So we will draw columns, beams, and slabs similar to that of other stories. So select quick draw columns, and select the columns, and draw the columns. And now draw the beams using quick draw beams columns. And now draw the slabs using quick draw wall floor plan. So we are done with columns, beams, and slabs for story 15 to 19. Now we move to story 21. So first we will draw the columns, quick draw columns for story 21 to 23, 20 to 23. And now we will draw the column beams using quick draw beams. And now we will draw the slabs. So far now we have drawn the columns, beams, and slabs for all different types of stories. So now we need to assign the dead loads and live loads. So dead load is same for all sets of stories. So first we will assign the dead loads for all stories. So click on all stories option, and move to story 1, and select these slabs one by one. So total 147 shells. Okay, 147 shells are selected, and we need to assign dead load of 2 kN per meter square uniformly. So click on assign and shell loads uniform. Here load pattern is dead, and we need to give the load of 2 kN per meter square and the direction of gravity. So click on apply and click on OK. So we can see the dead load of 2 kN per meter square is assigned on each floor. So now we need to apply. The live load on different sets of stories. For that, we need to select similar stories and select this story. And now we are in story 1. So for assigning live load for set 1 to set A, for applying the live load for story 1 to story 8. So select the shells in story 1, which are similar to story 1 to 8, one by one. So according to data, we need to apply live load of 5 kN per meter square. So click on assign and under shell loads uniform, and change the to load pattern to live load and load of 5 kN per meter square uniformly, and the direction of gravity apply, and click on OK. Okay. Now moving to story 10. So select similar stories and select the shells where we need to apply the live load, and under the assign select shell load of uniform of load 4.5 kN per meter square and load pattern live in the direction of gravity, and click on apply and click on OK. So we're done with story 9 to 14. Now move to 16, story 16, and select the similar stories and select the shells where we need to apply the live load of 4 kN per meter square. So select the shells carefully and assign the live load of 4 kN per meter square under shell loads and uniform live load in the direction of gravity, and click on apply. Okay. Now we are left with only one. We are left with story 22, 23. So moving to story 22 and 21. Okay, select the shells and set that to similar stories and select the shells and assign the shell loads on the uniform of load 3.5 kN per meter square in the direction of gravity, and click on apply and click on OK. So we're done with assigning dead loads and live loads. So we need to give the cladding loads. Okay, so for that first we need to use the auto cladding option. So auto draw cladding option, we need to select the auto draw cladding option. Use floors cladding options, and in cladding options use floors, and click on OK. Okay, AutoClad drawing option is selected. So we need to apply cladding loads. For that, uh, first we will move to story 1. So for the cladding load is applied on the external beams. So for that we need to select the external beams of different stories. Okay, for that we need to go into use similar stories, and we need to carefully select the external beams only. So for that, select okay, we have selected the external beams from in story 1 to 8. So we are assigning the cladding load of 0.2 kilonewton per meter square, which is a uniform and assigned, and in frame loads distributed, and load pattern is dead and in the direction of gravity, and uniform load is 0.2 uniform load is 0.2 kilonewton per meter, which is given in the data, and click on apply. So we can see the cladding load of 0.2 kilonewton per meter is assigned on the external beams. Okay, so moving to story 9 or 10. So we are in story 10, and we need to select the external beams to apply cladding load in story 9 to 14. So select the external beams carefully. So we're done with selecting the external beams, and we need to assign frame loads distributed of 0.2 kilonewton per meter square, and click on apply and click on OK. So we can see the 0.2 kilonewton per meter cladding load is assigned on the external beams. So now moving to story 16. So under design, under display, click on undeformed shade, and we can see a similar story option, and click on similar story option, and we need to assign cladding loads in story 15 to 19. So select external beams. For that, select the external beams carefully. So now we have selected the external beams in story 15 to 19 and assign the cladding load of 0.2 kilonewton per meter. So a cladding load of 0.2 kilonewton per meter is applied on the external beams in story 15 to 19. So now moving to story 21 to 21. So under design, under display side, select similar stories and select the external beams for applying the cladding loads carefully. Okay. Now assign the cladding load of 0.2 kilonewton per meter. Click on OK. So we can see the 0.2 kilonewton per meter of cladding load is applied on the external beams in story 20 to 23. So now move to story 23. So as we know, the story 23 is a top roof and there is no need of cladding loads. So for that, we need to remove the cladding loads in story 23. For that, we need to select one story option. For that, display, and click on one story and select the external beams. And we're going to remove the cladding load in story 23. So select assign and frame loads distributed and click on delete existing loads so that it will delete the cladding loads present on that external beams. So click on apply and click on OK. So now we have removed the cladding loads from story 23 and also moving to the base. So we need to change the the joints in the base to the fixed. So for that, click on first select the joints in the base and click on assign joints, and there we can say restraints, and under restraints select fixed and select apply and click on OK. So for now, we have assigned dead loads, live loads, and cladding loads. So we are left with wind load. For that wind load, we need to we need to define the load patterns. So we need to add wind in the load patterns, and type is wind, and IS auto lateral load is India standard IS 875-1987. Click on OK and add new load. And now we need to modify the lateral load corresponding to our building, which is located in Bangalore, which is to be built in Bangalore. So modify lateral loads. Okay. So there is no need to change the exposure and pressure coefficients and wind exposure parameters. Okay. Now coming to wind coefficients, we need to find the basic wind speed in Bangalore. Further, we're going to use IS 875-2000. So open IS 875 and go into appendix, opening appendix A. From our appendix A, we can find the basic wind speed in Bangalore is 33 kilometers per second. 33 meters per second. So change that to 33. And for terrain category, again open to IS 875 1987 and go to 5.3.2.1, clause number 5.3.2.1. Under 5.3.2.1, Bangalore falls under the category of 3, that is terrain with building structures up to 10 meters in height. Okay, so select terrain category as 3 and structure class. For that, again open IS 875 and see the structure class. So we can see our building height is 69 meters, that is 23 into 3, that is 69 meters, which is greater than 50 meters. So it falls on the class C. So structure falls on the class A, and this coefficient. For that, again I is 875. So we are assuming that a probable design life of structure in ES is 50. So for 33 meter per second, the risk factor is 1. So click on, so risk coefficient is 1. So there is no need to change that. And coming to topographic factor, that is K3 factor. Again, we need to use IS 875 and below clause number 5.3.1. So from that, the in Bangalore the upwind slope is great. In Bangalore the upwind slope is greater than 3 degrees. In Bangalore the upwind slope is less than 3 degrees. So the topographic factor K3 is to be taken as 1. So select topographic factor 1 and click on OK. So we have defined wind in load patterns and click on OK. And now we need to assign the wind loads. So click on plane view and we need to change into elevation view. So for that elevation view, click on set elevation view and set to section A and click on apply and OK. So we are assuming that section A is in the windward direction. So we need to find the wind pressure coefficients. So for that, select for that. So for that, we need to find the wind pressure coefficients. So wind pressure coefficients can be found out from IS 875. So now select the all stories option. So open 875 table 4. So building height ratio. Coming to our building is 69 meters high and width of the building is 18 meters. So ratio of building height to the width of the building is 69 by 18, which is equal to 3.83, and it falls under the category of 1.5 to 6. So under 1.5 to 6, and there are two subcategories. So and length and width of the building is same, that is 18 by 8, 18 by 18, that is 1. so it falls under first category. So here the wind pressure coefficients, according to IH 875 plan, or zero point 0.8 minus 0.25 minus zero point 0.8 minus zero point 0.8. So we are comparing IS 875 plan with our billing plan. So section A in our project is similar to section uh, A in plan IS 875 plan. So the wind pressure coefficient is 0.8. So click on all stories and select all the shells, cladding shells in section A, in the direction section A. And you can see all the sections are, all the cladding shells are selected. And we need to assign wind load. So for that, go to shell loads, and here wind pressure coefficient, and click wind pattern name is wind, and coefficient is 0.8, and coefficient is 0.8, and it is in the windward direction, and click on apply and click on OK. So now some of the cladding shells in section A are not there in higher stories. So and cladding shells in section B can be seen in section A. So for that, we need to change the elevation to section B. Click on apply, conclude. Okay. So select the cladding shells in section B, and in all stories, click on and select all the. So assign the wind load in section B for the cladding shells in section B, and under shell loads wind pressure coefficient, and it is pointed same, and it is in windward direction. Okay, and click on apply and click on OK. And setting the elevation in section D, click on apply, click on OK. So in IS 875, so we can easily compare B in IS 875 to the D in our project. So the wind coefficient, the external pressure coefficients are for B is minus 0.25. So we need to assign wind load with pressure coefficients of minus 0.25. So select all stories and select the cladding shells in section D carefully. And now we need to assign shell loads uniform wind pressure coefficient, and its wind pattern is wind, and coefficient of in B, so it is minus 0.25, minus 0.25, and it is in the leeward or sides. So click on apply and click on OK. So some of the cladding shells in section D are not there at top stories, so we need to select the section C, and we need to assign the wind loads, and it is same as in section D. So click on carefully select the cladding shells in section C and assign, make sure it is in all stories, and assign shell loads of wind pressure coefficient -2.5 with wind load pattern in wind and leeward or sides. Click on apply and click on OK. So now changing elevation to this set section 1. Click on apply. Click on OK. So now we can easily compare section 1 and 4 to the in this project to the sections C and D in IS 815, and the pressure coefficients for C and D are -0.8, -0.8. So we are going to use -0.5, -0.8 in sections 1, 2, 3, and 4, as some of the sections, some of the cladding shells in section 1 and 4 are not present at the top stories, and so we are going to apply in 2 and 3 sections. So we need to select the cladding shells in section 1, 2, 3, 4, and we need to assign the wind pressure coefficient of -0.8. So select the shells carefully in section 1, and now using arrows move to elevation view section 2 and select the shells. And now move to section 3 elevation view and select the cladding shells. Sorry, so we need to carefully select. So we are in elevation view 1, so carefully select the shells, cladding shells. Now move to elevation view section 2 and select the cladding shells fully, and move to elevation views section 3 and select the cladding shells, and move to section 4 elevation view in section 4 and select the cladding shells carefully. So we can see 122 cladding shells are selected, okay, and also we can see in the 3D view diagram. So now we need to assign wind pressure coefficient of -0.8 according to IS 875. So assign shell loads wind pressure coefficient -0.8 in leeward or sides, that is sides to A, and click on apply and click on OK. So for now we are done with assigning dead loads, live loads, cladding loads, and wind loads. So change the elevation plan, select plan view and select story 1 and apply and click on OK. So here in story 1 we can see the wind loads which are assigned, okay, which are assigned, and now we need to use extruded view for frame objects. So use extruded view for frame objects. So extruded view for frame objects is selected. You can see that. So now we need to run the analysis. So under analyze, so run analysis is there. So before that we need to save the file. So it will asking it will ask to save the file, and we will name that as final project and click on save. Upon saving the file, it runs the analysis. We can see the status here. So the analysis is done, and we can see the displacement units here in the 3D view tab, and using rotation you can see the clear displacements. Okay, now also we can check the forces and shears, forces and movements under display. Here forces stress diagrams under frame or link forces. So we can see the shear 2 movement 3 all the diagrams we can see here. So we have done the analysis. Now we have to check the design. So for that, under design, so concrete frame design and view device of preferences, and see that IS 456 2000 is present, and click on OK, and click on design, and we need to start design check. So click on start design check, and then it will automatically check the design. You can see the animation here. Analysis and design sections differ for 705 concrete frames. Do you want to reiterate analysis and design? So there is a notification saying that there are 705 concrete frames which are failed. So it is asking to reiterate the analysis and design. So before drawing the columns and beams, we have defined column auto select and beam auto select in frame sections. So it will automatically select the least dimensions. So when it automatically selected the least dimensions, so 705 concrete frames are filled. So we need to change the dimensions for beams and columns. For that, we need to click on S, and there is no need to change manually. It will automatically change, and it will run the analysis and design automatically. And click on S. And here we can see the analysis is running after iterating the 705 concrete frames. So now it automatically, so it's saying analysis and design section differ for one concrete frames. Do you want to reiterate an analysis and design? We will select that manually. So click on no, and it is asking, do you want to select that item? Yes, we will. We want to select that item. So now, so analysis and design checking is completed. Now we can see the select any frame and right click on it, and we can see the design properties or design information, and also we can see the structure layouts on the model, and we can see the reports, project reports. When we select project report, right in here it is. So here it is the project report. Now this whole summary of the 23-story building. So it is processing. So here is the detailed project report of this 23-story tall building. So here we can see the detailed project report. Then there are properties, assignment loads, and applied loads, and load cases also. So here we can see the load cases. So this is the project. This is the final project on 23-story tall building design by Skyfi Labs. So thank you.